Hi everyone, today let's solve some problems from the 2023 AMC 12B. Let's start with problem 20. The problem reads, Cyrus the frog jumps 2 units in a direction, then 2 more in another direction. What is the probability that he lands less than 1 unit away from his starting position? Okay, so let's start with this problem. We know that Cyrus, let's say that he starts at some point A here. Then we know that if he jumps 2 units in another direction, let's call that point B. Let's say if he jumps here, then that's going to be B. And since we want him to, when he jumps back, to be inside a circle of to be in close less than 1 unit away from A, let's draw a circle of radius 1 around here. Okay. Slightly make it look more like it. And as long as when we jump back to a point, let's say C, then if he's inside the circle or on the edge of it, then he'll be at most 1 unit away, which is what we want, right? So let's draw this. Note that it can be on both sides. Let's call this C prime. Okay, so we know that AC is 1 and AC prime is also 1. So when we choose where we jump from B, we're just choosing an angle. Let's say from this here, we're just choosing an angle, like for example that angle to jump at to land at C. In total there's going to be 2 pi angles, 360 degrees. As long as we choose an angle within this sector, then we know that it'll land inside the circle. So we just need to find the green angle over there. Notice that we know that AB is 2, BC is 2. So if we drop this perpendicular here, then we know that we can find that angle using the arc sign. So if we draw it like this, the same triangle, then this is 2, this is 1/2. And let's call this angle theta. Then we know that sine of theta will be equal to 1/4 because it's 1/2 and 2 on the denominator of that. And so if we take the arc sine of it, theta will be equal to sine of -1 of 1/4. And if I multiply that by 4, 4 theta would be equal to sine -1, 4 sine -1 of 1/4. Why did we multiply by 4? Because we need twice this for this part, and there's 2 triangles here, so that's going to be a total of 4. And this is the amount of degrees that we have, so now we need to take it over 2 pi. If I take both sides over 2 pi, that gives us a final answer of 2 sine to the -1 of 1/4 over pi, which gives us 2 arc sine of 1/4, which is answer choice E. Okay, that was really fun, right? Let's do problem 21 now. As I erase all of this. Okay, that did not turn out well. Okay, now let's do problem 21. A lampshade is made in the form of a lateral surface of a frustum of a right circular cone. The height of the frustum is 3√3 inches, and its top diameter is 6 inches, and its bottom diameter is 12 inches. A bug is at the bottom of the lampshade, and there's a glob of honey on the top edge of the lampshade at the spot farthest from the bug. The bug wants to crawl to the honey, but it must stay on the surface of the lampshade. What is the length in inches of the shortest path to the honey? Okay, so let's draw our frustum first. Well, I guess that works. So let's say that this is our frustum, right? Very nice frustum. We know that the radius of the top is 6. The radius of the, okay, let's finish this. The radius of the bottom is 12. And the height is 3√3 inches. So if we complete the cone like that, then we know that since this is 6, this is 12, then this height will also be 3√3. And we'd like to complete the cone because then we can uncoil the entire thing. And that's exactly what we're going to do now. We're going to uncoil the entire thing. So it's going to look something like this. Where this outer part is the lampshade. This outer part is the lampshade. And how do I know this? Because we know that the bottom is 12 has a circumference of 24 pi, and the entire, since we know that this is that this length over here is 24 because of the Pythagorean theorem. So that means that it'll have a total of 48 pi. So it'll be exactly half of that, which is 180 degrees. So we know that this is 180 degrees, and now we have 6 and 6 here as our two different radiuses. And by visualization, we know that we can let the ant start here and the glob of honey be here. Now, since we must stay on the surface of the lampshade, we can walk here until some point and then take the rest of the sector the rest of the way. We can't go straight, otherwise the ant will be walking in air, and that doesn't make sense. So how do we find this? Well, let's try to find the closest possible way. Okay, so here's a better diagram that I drew of this. Okay, so to find the shortest length, we can find the tangent point over here, and then walk the rest of the sector over. We know that this is 6, and this is 6, so that gives us a total of, since this is a tangent point is also 90 degrees, and we have 6 here, that tells us that by the 30, 60, 90 triangle, this length over here, this purple length, let's call it the purple length, we know that it will be 6 root 3. And since we know that this is 60 degrees by 30, 60, 90 again, then we know that this is 30 degrees, and we can just find this arc by doing 30 degrees over 360 degrees times the circumference, which is 12 pi, gives us pi. So our total length will be pi plus 6 root 3. And that is answer choice E. Great. Okay, now let's do problem 22, an algebra problem. Let's erase this. Boom. Okay, now it's erased. Now, problem 22 reads, a real valued function f has a property that for all real numbers a and b, f of a plus b plus f of a minus b is equal to 2 f of 0 f of b. Which one of the following cannot be the value of f of 1? Okay, so first, when we see functional equations, let's always try to plug in f of 0, 0. That gives us 2 f of 0 is equal to 2 f of 0 squared. This implies that f of 0 is either equal to 0 or 1. So let's first consider the case when f of 0 is equal to 0. Let's call this case 1. That means, then let's plug in b equals 0, for example. That gives us 2f of a is equal to 2f of a f of 0. But f of 0 is just 0, so that means 2f of a is equal to 0, and f of a for all a is equal to 0. And that just knocks off answer choice A. We can't have answer choice A anymore, because f can be 0. Otherwise, let's consider the case where, let's call it case 2, f of 0 is equal to 1. Then we know that, let's just plug in, for example, the same thing. Then that gives us 2f of a is equal to 2f of a, which agrees with the statement. So we know that this works as another case. And let's keep continuing on with this. Let's let a equal a and b equal a2. That gives us f of 2a plus f of 0 is equal to 2f of a squared. And we know that f of 0, what is this? This is just 1 from this case. So f of 2a would be equal to 2f of a squared minus 1. Now let's let a equal 1/2. Then that means that f of 1 will be equal to 2f of 1/2 squared minus 1. But f of 1/2 squared, that means that since even if this is negative, the trivial inequality tells us that anything squared will be greater than or equal to 0. So this can be at least 0. So this value will be greater than or equal to 0. And so this f of 1 has to be greater than or equal to -1. But looking at our answer choices, there's negative 2 here. So that means that we can't reach the answer negative 2, and the answer is E. And notice that we had to do both cases, because if we don't know f of 0 equals 0 only yields 0, then we aren't sure if f of 0 could yield negative 2. So that's why we need to do both cases. Now let's do the magic again, and I'll erase everything.